How's it going, everyone? Eulier Gonzalez here, and in today's video, we're going to take a look now at the subclassing, which is a way of how you can now allow objects to have access to property and methods from other objects, which is a great thing if you really think of that. Since this is a course taught by Will Sentence, shout out to Will Sentence completely. Uh, He is the CEO of CodeSmith, this software engineering and machine learning residency, headquarters in London, New York, and California. So the goal of this course is to look at how this object-oriented programming, this particular approach that comes from the 60s, to see how can we now write programs by combining its data and its functionality relevant into a same bundle so we can now build applications at scale in a professional engineering environment. So why do we need to look at how you can do this particular approach as a way to build this scalable things, you know, in this professional way? There's some couple verbs or actions involved. First, approach. It's important to understand this particular approach, and here I'm going to play devil advocate from the business people and the economy, where they realize so that to allow growth, economic growth, okay, so now everybody can have access not only to basic foods, so you can now go out and see that you have now bananas or avocados nearly where you live, all right, which is something that perhaps in your location that is not possible or feasible. Even let's say if you live in Nebraska uh, or London, all right, or in the south in the Patagonia. So the idea here is that if you are able to produce things at scale, we are now able also to grow. So now everybody can have access to all of these resources, goods, and service. And if we do that in a professional way, which is that you have a commitment towards that, uh, then you will see is now how this particular approach allow us to grow and produce more. So there's also some trade-off. Again, this is a quick side note, right? There is also some trade-off, especially is that now that you know that the goal of looking at how you can develop applications using this particular approach to produce things at scale, uh, the challenge comes now is that how we going to manage is that production, okay, as an individual and as a community and then as a collective and nations. Again, this is now the challenge. It's more like a philosophical and psychological challenge. Uh, but as you can see here, my point is this is not in a sandbox, right? So the thing that you're going to learn here as a software engineer, particularly looking at how now JavaScript or how the object-oriented programming plays out with JavaScript, is to see that even though that you're going to provide this to a particular company, you're not live in a silo. Okay, so whatever you're doing, especially here with JavaScript, is going to impact millions of people. But in any case, uh, today's video is make a quick recap of the core section and then dive deep into the factory functions or subclassing with uh, objects. And since this is a course from CodeSmith, which is now taking care. or the idea behind that is that it's going to take all of the people that come from boot camps and kind of accelerating into senior role, which is the need that the industry at 2024 actually requires. So, a couple of things, especially to develop as a software engineer, not only your analytical problem or analytical skill, how is your thought process, as well as your technical communication, is that can I implement your approach based on your explanation and also look at some good engineering best practice, soft skills as a way to have patience with yourself and with others, be empathetic, and lastly is the language and the specification. So the goal of this series of videos is to improve my technical communication skills as well as my analytical skills on the fly in real time. So now, when the time comes to actually show off my skills to people or my clients or companies, now I can do that in a fast way so we can move on to actually solve your problem, right? Because at the beginning, it's like, I don't know who are you, I don't know what you are doing. Let me see if you're actually who you say you are, right? And that's when you have all of this technical interview and that kind of thing. So, um, this course is laid out first as look at the introduction of the object-oriented programming, okay, where these things come from, and how now can we have this particular approach where people in the 60s say it would be great to have now data and its relevant functionality together, right? Because back then they have all of this line of code in this huge gigantic file, okay? So actually, it's not. It was not readable, not to mention maintainable and debugging, that kind of thing. So well, they come out with this particular model, and see we're going to see how can we or how that play out in JavaScript. So how can we create objects, object literal object dot notation, object um, dot create, which is a function that comes JavaScript built in from the object uh, built-in object from the language, and how in JavaScript everything is a language. Everything, sorry, everything is an object, and I haven't eat yet so far. So yeah, yeah, I'm doing fasting right now. I hope that after the end of this uh, video, I go out and I'll take a lunch. Good. So that in everything in JavaScript is an object, okay? And especially those objects built-in, they also are functions. So we're gonna see about that later. Uh, but then we look at how can we create objects using functions and how, which is solution one, and how that has trade-off because you want to create now the object that contains the relevant data and its functionality, but the problem is that anytime you create a new data or a new object from that, the data is unique, but the functionality does not, right? It's repetitive functionality. So you are duplicating your functionality every time you now have a new object created. In our case, when you create a new user, for example, in a game, okay? So how can we solve this, right? Okay, if you can imagine if you are now um, building a ping pong game and then you have a lot of user in there, you can quickly realize that if you have 200, 500, 1,000 users, That's not memory efficient. You have to now buy some new hardware as a way to provide this to a lot of people. It's like, would it be a better way to actually abstract the or grab the functionality into an object, okay? And every time we want to create a new user with the relevant data, we bound that to the function uh, or the object functionality. And that's exactly what it's doing using the object of create, thanks to the prototype change. Okay? So with the object of create, we can now have much more fine control about how we're going to create the bound. So again, we have much more control about what this object, what this new user can have access to. All right, which functionality can have access to, and that is the solution to here. Okay, so we got now is this object of create where initially is an empty object. Okay, and what it's doing here is to set the property called proto dunder, okay, and bound to this object called function store. So function store is going to bound to the uh, prototype of this object. All right, and see in there now, since this object contains is the increment and the login. All right, so now you are accessing to the properties and methods. And this is one of the things that I really don't like, the word inheritance, especially in JavaScript. You're not you're not getting you're not you're not passing, yeah, you're not getting things. If we talk with technically speaking, you are not getting things from other objects. You actually creating is a bound to that. That's a more clear definition, and that's one of the things that I don't really like the word inheritance. But again, this is for historical purpose. So this is the way of how you can create objects. So this is the sophisticated way of how you can create objects. Uh, the thing here is that this is something that is handcrafted and is manual, that you have to create these objects anytime and also manually set the boundaries. Okay, manually indicate what are these properties that this object can have access to. So you can imagine if this object now can, if you want to provide now access to several functionality here, you can imagine that this becomes quite long and tedious, right? You can define it as another functionality two, or functionality three, and functionality four, you know. But again, the thing here is that you have fine control about who can get access to. So this is this is a thing that you're not going to see too much in production code. Okay, this is the sophisticated way of how you can now create this bound. And now the new specification uh, on the EX 2015 introduced the new keyword to say, hey, let us, anytime you use is the new keyword here, and this is part of the diagram here and how it's going to bind that, okay, like that, exactly. You're going to bind that as it is. And now let us handle is the bounding process for you. Okay, so we're going to automate that binding process for you. So you only uh, focuses on creating these data uh, and the proper functionality. So this is a particular way of how now the language allows you to define is the data in a function constructor, okay, as well as it is methods or functionality inside of this object called prototype. And here is something important to know because functions, everything here in JavaScript is an object, all right? But functions are special type of objects. It's something that we're going to take a look at later with class, which are a special type of objects. In the case of functions, uh, they are callable, okay, so you can run given parentheses, and uh, they act as an object. So they have this duality here, this object function combo. So when you want to access to a method, a properties in the object form, JavaScript will take a look at a property, a hidden property called prototype. Again, this is something that will work in, let me see here, so the fundamental object. From the definition here, as you can see here, property of a function prototype object, okay, it has is a prototype. So the specs here is talking about is that, hey, any property, any hidden property for internal use will be defined under square bracket here. So it will have this property, okay, which is going to behave like the object of prototype here. Where in there you can now is define property in like key value pairs. So because now this is pointing to the object of prototype, and the object of prototype has all of these property and methods, has some property is prototype of, property enumerable, that kind of thing. Uh, the function of prototype object has also some inner methods as well. Something that we're going to see that later, like call, for example, here, uh, as you can see here, the apply, bind, call, constructor into string. Okay, so why am I talking about this? Because functions and objects are almost everything here, especially if you're going to work in JavaScript. Primitive objects and functions is the way how now you create these applications at scale using this particular approach. Okay, but the thing here is that now the function prototype or the function, it has this hidden property called prototype, okay, that contains is all of these methods that most of the time developers out there they have barely used. They don't know if they exist. They don't know actually how they work. For example, like apply, bind, and call. Okay, and how by using this you can define is which content the value of this you want to be. So we're not going to go there because we're going to see that later. But now that we know that this functions objects contain these properties, okay, uh, and methods, the way how now can we define or create objects using now the new keyword is by first define a function constructor. What you're going to define is all of the data, okay, using the keyword this, and then you define all of the properties for that you want to work with, and then it is functionality. But the functionality will be under the prototype. Remember that after all, uh, this function constructor which is an object function combo, uh, you're going to define is this property under the function constructor, pretty much like this, okay? And then it is functionality under the prototype, okay? And so that's it, right? You have your data layer, and then you have your functionality layer. So this is something that is now you're gonna see a lot in professional code, uh, and now these new specifications from Javascript say they are ashamed of the prototype nature of JavaScript. Okay, so they decide to make the objects creation uh, a little bit more like traditional object-oriented programming. Okay, so for example, like in Python or yeah, like for example, like in Python or C++, when you have now your class, you define your attributes, okay, and then the functionality that you can apply and you want to apply to these methods. So that's great. That's cool because we now this syntactically sugar uh, behind the scenes is doing this, and this is something that we're gonna see later on. But before that, we need to take a look at what will happen if we, for example, add new functionality, nested functionality inside of the prototype. Okay, so this is when now JavaScript and the value of this becomes quite cumbersome. Why is that? Because since the value of this has 7 to 8 rules that apply depending on the context, okay? So here, let me actually take out zoom here. No, what is this? Oh my God. No, what the heck? Here, as you can see here, okay, what will happen if we now uh, adding new functionality to this? In this case, the increment uh, function, you say, hey, I want you to now add something. But I want you to point to the relevant data and then update or perform that transformation. Make the uh, trigger that functionality. The question is that when now functions here are created, okay, and in the case of the this value, again, it contains several rules, particularly here on the functions. Uh, One of the rules, especially when you're working with this inside of a function, it say it'll be whatever is on the left side. That's one of the rules, okay? Let's say rule number one. However, because in a particular case, since we are now creating a user, okay, and then we increment that, we call that function, okay? When we call that function, we are creating is a brand execution context where you're going to now say, okay, this function is something that I'm going to have in local memory, okay? And then I'm going to run this add one. When we run the add one, it creates a new brand execution context, like you can see in the diagram, okay? But because the value of this is whatever is on the left side, what happens is that if there is nothing on the left side, by default, you get this value as window object. So we started to now modify is the window object in this particular case. How can we fix that? Some people actually now wants to hold the reference on a var uh, before that, and then they now pass that particularly this value to the function. So now it makes sense to actually work with the current data. In other words, it's a, hey, let me now here define is the value of that for self, and that will be this. And from there, okay, now that I have the relevant data, now that I pointing to the relevant data, okay, this is what we can do. In fact, that's actually quite a accepted design. But now with arrow function, uh, what it's doing is let the value of this, you have now another rule. Let the value of this, when you're using the arrow function, to be lexical scope. It means that whatever I write this value, it'll be the the value of this will be whatever I am right now. And that is part of the lexical statically scope, which is sometimes in some language, particularly in this case, it actually helpful as a way to now access to relevant data. So in this case, instead of actually do this, we say, let me add one, let me define a const add once, and define is an arrow function where we can now the value of this, okay, where initially in an arrow function, as you can see here, this value from the ambient docs, okay, ta, 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 specification, the examples here. This is this in function context. We want to show is that this in arrow function as it is. So arrow functions create closures over this value. And the closure is just a fancy name to say, hey, sorry. And a closure is just a fancy name to say, hey, whatever whatever valuable, whatever variables we get, where we define this, okay, I want you to now make it available with this. So this value of enclosing execution context. So in the following example, in the exactly value of the enclosing execution context. All right. So in the following example, we create object with a method get this getter. So the return a function that return the value of this. Okay. So when we call this in this particular case, all right. So now that when you run the get this getter, the value of we create a new branch execution context. Okay. When you say, hey, this getter, okay, let me return with the value of this, which is whatever I am inside of this function execution context, and then return the getter. In other words, is that what is the value of this at this moment? Okay, is getter, like so, is exactly, is now whatever is the value of this inside this getter can be set in the call, which in turn set the return value of the return function. We will assume that this getter is non-strict function, which means it is contained a non-strict script and not further nested in class or strict function. So when you call this, all right, it'll point to this object. But again, it's creating a closure, and this is something important here. By creating a closure, okay, it's say I'm going to now get access to the property and methods, or in this case for the variables that were defined outer the scope of this, which is in this case this object itself. Mhm. So when we test this, oh my God, no. So when we test this, inspect here, like so, we will get this. So now the object here is this object, okay? It's an object that contains this scope, which is a get this getter, and also a prototype here, okay? And get this getter now has a also the land the name because it's a function. It also contains a prototype where this is now how we're going to inherit or how can we have access to all of the uh, functionality from the function object constructor, okay? And similar to the prototype here, this is now how can we have access to the object prototype or the functionality from the object until the proto is null, as you can see here. Mm, bind call constructor, exactly. And then you take a look now at the prototype here, where it points to the object itself, and then it points to null. That's what it is. So, all right. So because now this is the object, okay? So now this is our object as it is. We want to see, we want to know is what is the value of this because after all, it's creating a closure. Subtle difference here. It's creating a closure. Arrow function create closures over this value of the enclosing execution context You see? So this is the enclosing execution context, and now it's saying, hey, I can have access to all of this property and methods from that. Even though you can extend here this object, okay, that's quite interesting. You can say, hey, oh come on, you can say, hey, I want you to define is, for example, increment, like so, like increment, for real, okay, increment. Um, you can say score, type of score, score of 10, right? Oh my God, score of 10, and name like Julia, right? So, and then I don't think you can show the file because it's a redeclaration here. Exactly, redeclaration, exactly. And there you got it, right? Okay, so because now the value of this, when you use another function, you create a closure on the current execution context. It means that you can have access now here, okay, to the outer to the outer function or to the outer variables uh, from here. Okay, in other words, you can have access to the object. So let's take a look. Let's take a look. Let's take a look. So let's define here the const called function here to see is that when you run this as a way to get uh, as a way to get the this value to see what is this value. Okay, when you from the get this getter, when you run this function which will return you the this value. Okay, I want you to now do something like this. Is this function, okay, that when we run that function, okay, is this function, because after all, we're passing is a get this getter, okay, so we're gonna receive is a function, an arrow function. So is when running this function is the same as the object, and it says true. So in other words, the function here is actually the object itself. That is pretty powerful, bro. That's pretty powerful. That's one of the. Oh my god, I really love this closure feature. Well, it's JavaScript. You gotta love it. I really love this closure feature. Why is that? Because now, anytime you run this function with the relevant data, in our case this, okay, anytime we create a function, uh, here, for example, anytime we create an object, let me in fact do this here. Okay, great. So anytime you create an object here, all right, uh, and for some reason you want to get access to the current to these objects, okay, by defining a function there and then return the value of this from a arrow function. The value of this is a rule. The value of this inside of the arrow function is a closure of the surrounding execution environment. In other words, that when is this surrounding, see here? So arrow function create closures over the this value of the enclosing execution context. In other words, that those closures are backpack or this persistent store that you can have access to outer functions or to outer variables from an inner uh, function scope. And that's pretty powerful because with this you can now work with the relevant data, okay, to change that data or to perform some uh, oh my god, to perform some sort of uh, yeah, and to perform some sort of function, to perform some sort of um, functionality to your data. So this is pretty powerful. And when you take a look now at this, okay, what it means this when you're now using is the lexical here, you're saying is that the value of this on an arrow function, it'll be the enclosing execution because it create a closure of the execution of the enclosing execution context. In other words, when you run this function, the value of this will say, hey, I'm going to create a closure as a way to save all of the property and method. Because remember, when you run a function, it's over. You don't go back. JavaScript doesn't go back to that, not at all. And the way to persist this state, uh, the way to persist is the lexical or the uh, local variable environment or a variable environment is through closure. That's pretty powerful. So with this now ability, okay, of the this, with this particular role, now it say, let me now create is this closure over of the uh, enclosing execution environment. In other words, is where this function is invoked. Oh, this function is invoked is here, but what is here? This, you know, what are the uh, variables that I can have access to? Okay, in this case, it's from whatever you have in the user creator. What is that? Name, score, and also the data, and also it is properties. Increment, login, and also it is methods here. Increment and login. So that's pretty interesting because with this particular piece of code, okay, uh, where now once you truly understand this, you will now move forward, blazing fast, especially to deliver results to company, which is after all one of the reasons why they hire you, right? Hey, please provide me the value here. Oh my God, closures are closures is one of these bonus features that I really love about it. Oh my God, holy, yeah, oh nigga. Oh, 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 oh. Holy yeah. But be careful if you combine the method object without calling it because, again, it's in closing execution context. Be careful without calling it because get this getter is still a method that has varying this value. Calling function in the following example return the global this. Because it followed the this from the function two, which is the global this, since it is called without being attached to any object. So if you don't run this, okay, if you don't run this exactly, if you don't run this, uh, okay, because as what you're creating is a closure. And the way of how you get access to the closure, to this variable that you hold there in a persistent way, is by calling that function. It makes a lot of sense. This behavior is very useful when defining callback. Exactly. When you want to hold the value of this, okay, and then when you return that, or they hold the value of this data when you return that, okay, work on that data. Usually each function expression creates its own this binding, which shadow the this value of the upper code. Now you can define function as arrow function if you don't care about the this value, and only create this binding when you do in class methods. The example of set timeout. hmm Oh my god. Oh my god. So the class method is it's like creating its own closure there. Okay, that's interesting. That's interesting. That's interesting. That's pretty interesting. Okay. Um, so once we look at this solution, at the solution three, right? Uh, for how can we create now our data, relevant data and our functionality using the new keyword and how the new keyword works, because when you put the new keyword in a function construction, it'll say, hey, let me first define the value of this as an empty object, okay? And then attach whatever property uh, to this object, okay? And then let me automate the reference or the prototype change for you by looking at the proto hidden property and bind that to the prototype function constructor. In other words, is to this prototype here. So let me bound that to the prototype object constructor. So if you can see that in the previous uh, solutions, we have to manually say that, okay? And here, all that thing is happening behind the scenes, uh, And this is how you can now create is this binding by default. And lastly, it returns this new object created. All right. But what if when things started to get a little bit more complicated? So for example, what if you now have an op you define a user with some of the data and methods that you can apply, right? Name, score, increment, and logging. But what if you want to define now certain functionality to a specific use case? Remember, when that happens is because business people needs that. Okay, it's because a new challenge that emerge in the field, whether it's on e-commerce, hospital, or healthcare, or finance. So now we want is to provide some features uh, to the customer. So how can we now inherit those properties, or in this case, access? That will be a proper way. How can we get access to all of this uh, definition that we create from the user? Okay, how can we get access to that? And then, um, yeah, how can we get access to all of that data? All right, or functionality that we defined previously. So while reusing that, or creating our own functionality for this new user, let's say pay user. Uh, and that's why we have, for example, is to take a look at how now can we inherit property and methods uh, from the object built-in as well as the function built-in. Arrays built-in is also uh, a built-in object that we can inherit some property methods, string, numbers, symbols, boolean, as well as map, set. Let me actually look at the built-in object here. Built-in objects here. Standard built-in object. Okay. Function properties. Exactly. So each one of them has now an object function combo. All right. Global functions. Uh, Fundamental objects. Object function boolean and symbol. Error objects. Okay. Number and date. And another object. Uh, Text processing, index collection, interesting here, like an array. Usually we work with arrays, okay? Key collections like map, set, okay? So map is only storing unique keys, whereas set only store is unique values, okay? And anytime you update a string, a key that already exists in a map, or anytime you want to uh, uh, change the same key value, it will update that value. Structured data, array buffer, and all of this now have is from the prototype built-in objects, managing memory, control abstraction objects like iterators, async iterators, promises from the async nature, generator function, async generation function, generators, async generator, that kind of thing. Reflection, internationalization, and this is all the building object that we have right now. Okay, so if you are familiar with this, for example, the function property, most of the time, perhaps the function property that we use is like parse float, parse in, is infinity, usually not evolve, decode URI, uh, fundamental objects, function, object function, boolean, and symbols. uh, Error objects, number and date, which is our primitive, okay? Text processing, string and regex. This is also something interesting that comes with the new specification. And index collections like an array, as well as map and set. And how you can combine these index collections in key collections as a way to now work with large data sets. Okay, so hey, give me is based on this collection of data. I want to get is only the unique values uh, from a particular property. Things is gonna be wildly interesting here. Very interesting. That makes a lot of sense. Okay, that makes a lot of sense. So okay, so we look now at the default prototype change. So what are these built-in objects and how can have access to this property and methods? So for example, objects. Okay, that all this is a function constructor. Uh, so here we look at now this. So anytime we create an object in JavaScript, by default JavaScript will look up to the proto. Okay, this is the default behavior. It will look up to the proto that holds that points to the object function constructor prototype to have access to all of these property methods. You continue to look at the proto, uh, and the last change of that is the object, where now the proto points to null. So if you look at now the arrow, the function, anytime you create now a function, JavaScript will do the same. You say, hey, let me take a look now at the proto, uh, which points to the function constructor object. Let me take a look now at the proto, which now point to the object function constructor. Let me now take a look at the proto, which points to the null. Stop. If you don't, if I don't lose my share, let me actually take a see this in action. Okay, so we're gonna create a function called um, haha. Naming things and catching is one of the hardest things in JavaScript. Yep, or in computer science. We say hola, right? Hola function. So hola function. We create this function here, hola, right? And what you're gonna do is to say, hey, I want to just print on the console, hola. Okay, cool. Now if we want to take a look at the hola, so anytime we run this, okay, JavaScript will say, hey, let me take a look now here at hola. In hola, let me take a look now at the prototype. The problem with this thing is that look at this. Um, this is part of the bad naming the specifications because prototype is what holds a reference to the function constructor here. In this case, as you can see, prototype or the underscore proto. Okay, that now JavaScript say, let me run this, but first let me take a look at the proto uh, here, or this prototype. I think they changed that. Interesting. It's like they changed that. Mm-hmm. So now, okay, interesting. They changed that. Okay. Before it was before it was called now Dunder Proto Dunder, which contains a reference, but now it is called this prototype with with this symbol. Less in mind, yeah, with this symbol. So now this prototype is pointing now to the function constructor object prototype. That you can have access to all of these properties here. Apply, arguments, bind, color. Then that object also has a proto or a property, hidden property like this that is now pointing to the object uh, function constructor. One of them is the function object constructor, and the other is the object function constructor prototype. That this can have access to all of these properties. And lastly, as you can see here, which is the proto that contains the last reference, it will point to null. Oh, in fact, interesting. Okay. Um, so now the specification might change a little bit. Uh, that's quite interesting. Oh, there you go. It's on the okay. Mm-hmm. The head is null. Exactly. So it's this one. Prototype. Oh my god. Oh my god. Okay. So okay. So every object has a property called prototype. Okay. In this case, this. Where you're going to take a look now. The prototype holds a reference to the object function constructor. Okay. And until it reached to the last proto, that's one of the things that I really hate about JavaScript sometimes. It's like we change name. I know you inherit a lot of uh, learning things along the way, uh, but let's try to be consistent as much as possible. Here we're gonna call this is the proto because this is something that is shown here. That okay. So the proto, as you can see here, this proto has a reference to the function constructor apply argument bind call, where inside of this the prototype has a proto reference to the object function constructor, and lastly, this points to null. So looking at this particularly default prototype change is a way of how now can we have access to property and methods. Okay, so calling this inheritance to me is something that is quite uh, misleading. Quite is not actually describing the proper mechanism because what you're doing is just to creating a reference to access property and methods to that, not sticking to that or not getting from that. So yeah. Anyway, so now that we know this default prototype chain, okay, uh, we look at the subclassing here as a way to say, okay, how can we know, as I mentioned before, how can we know is to say, I want to reuse the existing functionality and then implement particularly one as a way to provide or to cover a business use case or to provide more features, supply, and that kind of thing. Okay, so first we look at this introduction to subclassing. So this is exactly what we're describing here. And first, how can we make that subclassing? By first looking at factory functions. Okay, so this subclassing here, so with this solution two of the subclassing, we're going to have a lot of finer control of how we're going to create this bound too. Okay, in this case, how can we have access to all of these property and methods for that? This solution here, by using the optional create, uh, that's actually quite lengthy and verbose, in my opinion. Uh, like this one, yep, like this one. Here, what we say is that we're going to create now this function constructor. Remember, following is the solution two, which is using the factory subclassing. So here we are not using the new keyword. We are just manually in having much fine control about how we're going to create this reference is by looking this. So function user create name score. Okay, we create another object with the object dot create, which initially is an empty object, where we now pointing to the function or the object functions, the functionality, and then we add the proper methods that we're going to do that, and we then after that we create the object. Okay, we return the object. So far so good. Okay, that's great. And when it comes to define now this new functionality, we replicate the same behavior here. So hey, we want to now create this new pay user. Okay, what you're going to receive is all of these property and methods that we need to. Okay, and then first things first, we're going to create now the new object and bound the reference to this base object that we want to have access to as a way to uh, access to the property and methods. Then we now another manual step that we have to do, okay, is to set now the prototype because this is something or the proto, you know. So set now the reference, okay, to their methods, to our own current methods, as well as to the uh, uh, method that we want to access to. That's interesting here. That's very manual process here. So first, especially when you want to do subclassing with factory function, is that you first create you first define is the object, okay? Uh, you first define is your name. You first define is your object, where you're going to now call is the function constructor from the property method. Yeah, the function constructor, okay? Uh, you also want is to um, yeah, you also want is to now uh, create the reference or set up or create the bounding, okay, because user.creator is like, okay, uh, now that we create, so now that we are running the boundary here with user.creator, uh, which now the prototype is there, but we need to actually update our prototype, which means that we need to actually not only have access to their methods, but also to our own methods. That's what we define here is the set prototype of. So give me is the object from there, okay, a new pay user, as well as the pay user function, okay. So give me the prototype. Oh, okay. So we're going to create now the bind to the object that we are creating from that, as well as our object that we have our methods, or current object that we have that contains our methods, and then we're going to add all of the property that we want to, and ultimately return is the object here. This is something wild because there is a lot of mechanism. Again, there's a lot of manual things that's going on, especially when you do subclassing here. Oh my god. Oh my god. Uh, uh, luckily for us, okay? Luckily for us, now with the new keyword, it automates that process. Okay. With the new keyword, it automates that process. Mhm. So instead of having us to say, hey, user.call with this new context, oh my God. Mhm. Okay, okay. Including some factory functions here. Again, here we are now going dive deep into this, creating an object with sub-factory functions. Exactly. Creating an object with sub-factory functions, where here you are manually say, okay, because I want to because I want to have access to all of these property and methods, okay, from this class or from this object that I already defined, okay. So let me now create is first is a function constructor where I call this new object and I pass the proper property. Uh, yeah, when I call this new object, the user function constructor from our base class, and then let me now set the prototype. In other words, let me now have access to the prototype. Uh, and here I have to do this manually because again, when you are now creating an object from this base class, you only getting is their property and method. Okay, and how you can now make and how you can now add your own functionalities. That's what we use here is the set prototype of. So we're passing here now is not only is the new user that we create and whole is the uh, pointer to the prototype from this base class, but also we're going to pass this the object from our functionality reference. And then we added the property and method for that, and there you got it. Holy moly, bro. And set prototype off is a way of how you can set is the proto, is this reference that's going on behind the scene. Holy moly. we are now is running the okay, the pay user new creator. Okay, so we create a new brand execution context where you're going to receive the argument as Alisa 8 and 25 as their uh, pay name, pay score, and account balance property. The difference between a property and the argument is that property is the label, and argument is the value. Okay, so then we're going now to reserve spacing memory uh, for yeah we're going to reserve spacing memory for new pay user. Uh, okay, we're going to reserve space in memory for new pay users, and their value will be is user creator. Okay, so what is user creator? That's where we create a new brand execution context where we are passing is the value of new pay user, which is Alisa, and the pay user function, I mean this, sorry, pay name, okay, Alisa, and pay score. So once you create this new execution context here with the user creator, it say, okay, first, again, let me define is the parameter. It's going to be nasty. Let me define first the parameters, name and score, which the values are Alisa and 8, okay, um, which the value is Alisa and 8, okay. Uh, so not only am I going to create that object empty as a new user, I'm reserving space in memory, in the local memory for the new user that initially is an empty object that creates the bound to the um, object where it contains our functions, okay, like say names and increment. We create that bound. So in other words, we're saying is that hey, let's set the proto here to point to this object, okay, and then add a new user.name uh, object with the value is Alisa and assign Alisa to that. Add any property scores to the new user, which the value is 8, and then return that user. So now that we have our returning object, which their proto is pointed to user function, okay, that particular functionality, we need to also find a way that how can we set our own uh, functionality for this newly created object. So the way to do that is by saying object.setPrototypeOf, which is a badly name for this, object.setPrototypeOf, which is now pointing. Is when you create your pointer manually here. Hey, point to the functionality from the base class, as well as point the functionality to the pay user or this new functionality object, which is this one. And then is when you can create is all of this. So now this is when this is now, okay, okay, that's quite interesting. That's quite interesting. That's quite interesting. Creating an object with sub-factory function. Mm-hmm. Creating a function with sub-factory function. Okay, okay. Okay, create a sub factory function here. Exactly, create an object with sub factory function like this. This diagram help us to visualize by running user. Exactly. And the other is a diagram help us to visualize. Mhm. Let's walk through this code. Let's walk through this code. Exactly. God damn it, bro. No way. Mhm. Exactly. Exactly. The user here. Mhm. Exactly. The user one is gonna look up for the same name in global memory and doesn't find it, doesn't panic. It's gonna it's gonna freak out. It's gonna freak out briefly, and you take a look at the proto, where also we don't have that, and then you look at that proto. God, oh my God. So let's take a look at the let's describe because this is let's describe the lookup look lookup journey. Okay, so let's describe the lookup journey. God damn. Yeah, yeah. So let's describe the lookup journey of of calling. Okay, of calling is pay user one of pay 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 user one dot increment balance in the same name. Mhm. Let's describe the lookup journey of calling a pay user one. What's the name of this? Increase balance, increase balance as one, and pay user one same name. Wow. I know why I get it. It's because I love it. I need you people that actually know how these things work. What is the inner mechanism? How they actually, all of this abstract thing, okay, capable of now doing this, allowing us to do this. Hmm. Okay, that's interesting. So one, pay user, exactly. JavaScript, exactly. So JavaScript will call. So JavaScript will call. JavaScript will call increase balance. Okay, and I think it's much better put it to put it this way. Holy moly! Mira bien, ¿qué pasa? Okay. So JavaScript will call increase balance method by first take a look at the object, take a look at the use at the paid user one. Since it doesn't since it doesn't find it, yes, since it doesn't find it completely, since it doesn't find it, okay, it doesn't panic, it will look up, yeah, it doesn't panic, it will look up to, it will look up in the, in the dunder, in the dunder, proto dunder that points to the function constructor or to the object, to the object prototype in this particular case, to the object of prototype, okay, and points to the object prototype, uh, pay user functions, pay user functions, where it finds where it find the function and run it. But in the case, of a user two same name, it is one. JavaScript will call increase same name method or function. Same name method. I prefer to use function. uh, JavaScript will call the same name function, but first, look up at the look up at the object itself. Uh, does it find it? Does it find it? Does it? Did it found? Did it? Does it found it? Exactly. Does it? Is it? Does it found it? Does it? Exactly. Does it find it? No panic. It will look up. Exactly. It will look up at the. Mhm. Does it find it? No panic. It will look up at in the underscore proto underscore uh, which points to the prototype pay user function. Exactly, to the pay user function. Or did it? Don't find it. Yeah, didn't found it. Exactly. Or didn't found it. No panic. Didn't find it. Okay, didn't find it again. No panic. uh, it will look up up to the proto which points to the new pay user, in this case to the user function, which points to the prototype user function, where it where it found the function and run it, and run it. When it found the function and ran it. When it finds the function and runs it. Exactly. When it finds the function and runs it. Runs it. That's very manual process of how you can now share this. So this process uh, which is a famous senior uh, developer question. It's also why we have mhm, a new in the new spec. Which new spec? We talk about ECMA spec, ECMA spec, the extend. Of the prototype. Okay. Introduction. We take a look at here the class. Class declaration. And made it extensible via subclassing. Mhm. Holy moly. The sixth edition. Mhm. Accessor properties. Okay, class declaration, lexical block scoping, iterators and generators. Promise for asynchronous. Mhm. At the sixth edition. In the sixth edition. Yes, six. I get it. I freaking get it. EX6. Mhm. By new spec ES6 int. By EX6. Okay. By EX6. Mhm. There's a lot of Python. ES6. Mhm. Okay. From the ECMAC 6 for ES6 and ES7. But this is from EX6 from 2015, bro. ES6. Mhm. ECMA 2015. That's quite interesting. And that was a lot of time. Almost 10 years ago. What the F is this? Oh, this is not even updated, bro. This is, look at English. Google Chrome. JavaScript core. Mhm. But it doesn't have a list of ECMAScript engine. No, but this is the engine. What is the specifications, bro? Engine support. ES6 2015 and the X6 2006. Mhm. Even browsers, even freaking browser doesn't support that. Okay, okay, okay. Anyway, yep, that's very oof, powerful. Yeah, holy moly. Mm-hmm. What's the prototype? Exactly, exactly. Completely, completely. God damn it. Okay, okay. That was quite sick. I must say, I must say, I must say. Yeah, damn. Mhm. To whatever is on the left side, especially on this particular rule, that is one of the one rule of this. Pro- Prototype, because this is a function, you can take the prototype as well as the proto. Hmm. Call. in an array. Exactly, because we need to pass the relevant data to that. It makes sense. Mhm. Okay. So we make a quick intro here with call and apply. This is an interlude. This is subclass review and call and apply. So this particular approach, this particular approach is what allows us to share or allows to access properties from other objects from other objects. This uh, this is a sophisticated way of doing it. A sophisticated way of doing this. This is a sophisticated way of sophisticated completely. This is a sophisticated way of doing this. something that with the new keyword keyword we'll see that is way much more. So that we'll see that automate that bounding process, which is great, by the way. That automate that bounding process. But before looking at that, we need to see first how to run how to run functions where we can pass is the proper data to this mhm, keyword, okay, and it is it is argument. So call and apply, okay. So call and apply here, you guys, this screenshot and that kind of thing. Okay, screenshot, nope, and there you go. So let's let's walk through this code. Let's walk through this code, and this is the final diagram of this code, of this code. Yeah, man. So apply and call the uh yeah. So apply and call so apply and calls are needed as a way to provide relevant relevant data to the this this to the this value. Yes. So applying calls are needed as a way to provide relevant data to the this value. Yeah. So applying calls are needed as a way to provide relevant data to the this value uh, to work on in to work on. Apply passes arguments uh, as an array, whereas call as input, a single input. Mhm. Exactly. Apply path argument as as an array, whereas uh, call pass uh, one input at a time. In other words, followed by a comma. So follow by a comma. That makes a lot of sense. That makes a lot of sense. That makes a lot of sense. Subclasses in solution three. Exactly, because now subclassing in solution two, because we now have to find a way to say, hey, this prototype here, which will hold all of the functionality, okay? Uh, Now how can we bound to that? You know? Oh, to the object of create for them. Okay. All right. Okay. So that'll be all for this video. Take care.